Hi everyone, welcome to session 226, enabling AOSP FBE with Opti Keymaster. So for those who don't know, FBE is a File Based Encryption. It just means when you boot up your phone, the files are encrypted for security purposes. So we have had the high key AOSP Opti implementation for a little while now, but a few months ago, we received a report from one of our members that their board is not booting up when they have the FBE enabled. So we started an investigation, and this session kind of just summarizes the findings. Okay, this is just the agenda for the day. Okay, sorry. So first, we'll just go through what the problems are. Basically, we'll look at the boot flow when the FBE is not enabled, and then going through the boot flow again with FBE enabled and see what the problem is. And then we'll also go through a sample boot flow where we have 2 instances of Keymaster enabled. And then we'll just go through some of the things they are to do to sort of fix the issue. So now a basic boot flow without, just hang on, sorry. Okay, so this is a sort of a simplified view just to make things easier to look and understand. So basically, when you boot up a board, so the bootloader boots up, and then Linux, the kernel boots up. And then the AOSP init framework, it starts several services for you. And then for our sake, we'll just look at the relevant ones. So the Opti Keymaster service starts, and then the volume daemon vault starts. And it does many things. So for the purpose of this session, we'll see that it prepares the user data partition for vendor, which is /data/vendor, and in this case, this is non-encrypted. And then here, there is an order where the services start, but they do sort of get started in. They do sort of run in parallel as well. So, and then the Opti supplicant service starts as well. After that, we see that the Opti Keymaster client application that's on the normal world side, it connects to the TA via the OptiOS. And then OptiOS will load the Keymaster trusted application. The Keymaster trusted application, it creates a secret key that's used for several things. One of them is to encrypt the key blobs. And then this secret key is actually stored in the Opti secure storage location, which is the default, which is a data vendor T here. And once that's all done, we have a successful boot. Okay. So now we'll look at an example where the boot flow, with a boot flow where FBE is enabled. So same thing, bootloader boots, Linux boots, OptiKM service starts, and when Volt starts, now before it prepares the user data partition, it actually calls some Keymaster services to generate the crypto keys it needs for its crypto functions. So because it's calling the Keymaster services, the Keymaster service needs to, sorry, let me rephrase that. So now we go where in order for it to be able to use the Keymaster services, the Keymaster service has to be fully and completely started. But here we see we're still trying to finish starting the Keymaster service, and the supplicant starts as usual. CA connects to the TA TA is loaded, secret key is generated, but now the supplicant is trying to store the secret in data vendor, but it fails because it hasn't really been properly, it's mounted, but it's not really prepared yet by Vol, so we sort of have a chicken and egg situation here, so the boot kind of hangs, waiting for, with one waiting for the other. Now, sometimes, so in the report that we receive, it says sometimes it hangs, and in certain occasions it actually succeeds in booting up. So that was strange, and then we figured out it was this actually due to the board having two instances of Keymaster. Google AOSP by itself has a default software implementation of Keymaster, which if you're not careful and you configure both instances, what happens is so this all proceeds as usual. But when Volt starts, it enumerates all the Keymaster services and it says, hey, is there a Keymaster service available for me to create my keys? And then the framework says, okay, here you go. This is a Keymaster instance, but it's not the Opti one. It's actually the default software one. But anyway, Volt doesn't care. It just uses whatever is available to it, and then it actually creates the key that it needed. So it's able to proceed to prepare the user data, the /data/vendor, and then that actually allows the Opti Keymaster to complete its the starting of that service, because it sees that the secure storage location is available, so the boot completes. And so you might think that, okay, problem solved, I just need to enable the software, the default software Keymaster as well, and the problem is solved. But when the problem actually happens when you reboot the board. So on the second boot, again, this all goes through as, you can't see my mouse. Everything goes on as usual, and then when Vol starts, on the first boot, the key is already created and generated, so it knows that they exist, so it doesn't need to create again. And it goes on to prepare data vendor, and then supplicant starts, all the CA connects to A, everything is the same, but so the Opti Keymaster succeeds in starting as well, but then when Vol further down the boot process, Vol tries to calls the Keymaster service again, and it uses the existing keys created during the first boot to do what it needs to do to do the encryption decryption of the files. But now that we have two instances of Keymaster, the Opti one is hardware backed, so it actually has a priority over the default software one. So Vol, this time it calls into the Opti Keymaster using the key generated during the first boot by the default Keymaster, software Keymaster instance. And in the Opti, the Keymaster TA sees this key and say, hey, I don't know where you get this, but this is not the key that I generated, so it throws an error, you get another hang again. So I don't know what it looks like on the other platform, but on the high key you just see like a booting scroll bar that just moves along and it doesn't go into the home screen. So now we'll look at some of the things we have to do to actually get around this. So first thing is just to avoid having more than one Keymaster instances on your device. And actually we sort of asked Google about this, and for the implementation that we have right now is version 3. Version 3 actually only supports one instance of Keymaster, so it's actually not advised to have more than one. KM4 is a different story, but version 4 actually support multiple instances. It's mostly due to the Strongbox implementation, but we won't go into that today. And then the second, actually the second one is the most important thing, is we have to move secure storage out of /data. That actually is the biggest issue here, because where we had that chicken and egg situation is because Opti secure storage actually depends on /data/vendor to be ready. So 2 options here. One is to use a non-standard partition. So in AOSP, I think you have system, vendor, user data, cache, or whatnot, but just you have to, on your platform, set up something else other than those main ones. Or you can, like I think this is what Trusty is doing as well, use a RPMB partition for your secure storage. So when you design around this, there are other things that you need to do to just make things work. One of them is you have to add the appropriate SE Linux rules. So that's not explained here, but I guess when you run it, you see the denied messages. I guess you can just run it through the audit to allow process and just add the rules again to make things work. And then finally, the third thing is we need to start the supplicant and Opti Keymaster service before, start the service earlier before Vol, and make sure it's started properly before Vol even tries to start. So first, the non-standard partition on high key. The high key 620 board actually has the 960 is similar as well, but we have this partition here. The fastboot, NVMe, boot vendor. From boot on, these are like standard AOSP partitions, but in this case, we're sort of lucky because we have a partition that's not used for anything. So just as a proof of concept, we are using this as our non-standard partition for secure storage. And this is just a patch that we had to do here, where in the fstab file we're actually adding this NVMe partition, and we're just mounting it as ext4 so that we can actually read and write to it. And in this case, you also have to patch the Opti client to change the default secure storage path from the original data vendor T to persist/T. So if the other option, if you don't want to use a non-standard partition, you can use a RPMB storage. This seems like this is actually preferred by some of the members as well. Although it's a little bit more involved. First, you have to actually build OptiOS with RPMB support enabled. So it's just this flag here, and as starting out, we recommend just disabling the normal file system so that you only have one file system while secure storage file system to work with, so that it doesn't, make sure everything works and doesn't get in the way or confuse you. Again, if you try to enable RPMB in OptiOS before, you just things that you have to do. Make sure you get the device ID right, because the device ID must match the /dev ID here. And then, so you also need to make sure the RPMB key used in OptiOS matches the key value that's actually programmed into the device. And just be careful here when you actually, I'll go into that later, but when you have to be careful when you program the key, because if you lose it, then you have a RPMB device that you can't use anymore. And then OptiClient, the RPMB emulator is enabled by default, so you need to turn it off so that it will actually write to the real RPMB storage device. On the kernel side, this is just to make sure you can actually access and read and write to the RPMB device. There's a tool called MMC utils that you can install if you have to, if it's not installed by default. And then you can use this to test reading and writing to the RPMB device, make sure everything works. The key I've mentioned earlier, so you can use this tool to program the key into the RPMB device as well, but just be careful when you do that. Write it down on a piece of paper or something. So yeah, just general advice is to just make sure RPMB works before enabling FBE, otherwise you have several things going on which might be hard to debug. The other thing is the Android init process. So this is sort of a brief, like a summary of the stages of the init process. This is not an exhaustive list, but basically we have in AOSP you have a system init RC file and a vendor init RC file. So each init RC file, it defines I guess stages like early init, late init. So in each of these stages you can do things like create directory, set a property, or things like start a service, things like that, just to get your processes to boot up in order. So the order as execution is by row, meaning the early init system init RC's early init will start, and then vendors early init, and then systems init, and then vendor init, so on and so forth. It's sort of like a zigzag across the table here. So what we're doing, these are just approximations that can vary slightly with your platform, but so there's a bit of flexibility, but the gist here is that the Keymaster service must be properly started before Vol starts. So previously what we had was we would start the Keymaster service, and then Vol would start, and then the supplicant would start. But what we had to do to move things around and make sure Keymaster starts first is we moved the T supplicant and the OptiKeymaster process to start at on post the vendor's post FS stage, and then once that started, we actually add this. There's a wait for Keymaster executable. There's just an executable that waits till it's actually blocking. It doesn't blocking mean it doesn't allow Vol to start until it's sure that the OptiKeymaster service are completely started, and then once that's done, it'll pass through and let Vol start. So this is a sample init RC file on the high key. So you see here on post FS, we're starting the T supplicant and the OptiKeymaster services, and then on late FS, we're starting the wait for Keymaster services. You see the child system persist. All this is what is meant by preparing. Remember earlier where we see the Vol has to prepare data /vendor. So this is just preparing /persist with the proper file permissions and proper SE Linux context to enable access by, whatever service that needs to access it. And then finally, we see the boot flow where everything is fixed and runs properly. Firmware starts, Linux boots, and then now the opt Keymaster and T-supplicant services starts. And then vol starts, and vol calls the Keymaster service to generate the keys. Now opt Keymaster CA connects to the TA. The TA is loaded. It creates the secret key. Now the secret key is stored in the alternative partition or in RPMB partition. And now optkeyam is able to generate the key requested by vol. And then here we just wait for Keymaster service to complete. So now vol is able to continue and then prepares /data vendor, which is now encrypted. But at this point, we don't really care about this data vendor anymore because we're not using it for secure storage. And the boot completes, so everyone's happy, I guess. And that's it. Any questions? Nope. Good. Thank you. Have a wonderful day.